Alright guys, so now let me show you the equations of a progressive wave. I'm sure you've seen equation before. uh, the equations would look like this: y is equal to a sine wt to y is equal to a sine wt plus the phase angle, and 3 y is equal to a sine kx plus or minus wt, or they can write it as y is equal to a cos kx plus or minus wt, but the common one is this formula here, and sometimes this is also common. So you wonder where these formulas come from. So I want to show you. Let's do the sinusoid waves. So a sinusoidal wave is a progressive wave. It is a progressive wave if it travels through the medium. It can form a standing wave when two identical waves move in opposite directions, but you just have to know that, but it's not necessary for now. So let me just describe it. A sinusoidal wave is a wave whose shape follows a sine or cosine curve. A sine or a cosine curve, in case you've heard of a sinusoidal wave. So without wasting much of your time, let me show you the structure. It is a transverse wave, but there are some differences in terms of how it's drawn. So x, there is a point O here and some point B here. Yeah. So this is a sinusoidal wave. Yeah. So now I need to show you the formulas. The distance from here up to this point is the wavelength. So like, I want to show you how to find the displacement between from here up to here, like the formula we use for displacement at point B and at point O. So at point O, the formula is we use are y is equal to a sine wt plus the phase shift. But if you don't have the phase shift in your question, you can use this formula. Y is equal to a sine wt. I will show you where these formulas are applied. Okay, so these formulas are only used when you are at point O. Now, what happens if you are at point B? Okay, at point B, there are some changes that will happen, because we know from here to here it's not a complete circle, so meaning that there will be some adjustments to this formula. And like, if you don't have the omega in your equation, you can replace omega by 2 pi f. So meaning your equation can be like this: a sine 2 pi f. Now let me show you how we make the one for point P, how we derive. Of course, the formula is like this: a sine kx plus or minus wt. And you must know that if y is equal to a sine kx plus wt, if you see a positive sign, the direction is in the positive, in the negative x. If you see a positive, it's negative x. And if it's a sine kx minus wt, then they ask you to tell which direction the wave is going to. Just say the direction is in the positive x. Just do the opposite. If it's positive, then that means it's going to the negative. If it's negative to the positive, you might wonder why. Let me show you this. The restoring force, we know that F is equal to kx. There is a negative, and the restoring force opposes the motion of a wave. It points in the opposite direction, meaning that when it's negative here, the restoring force is positive. But when there is a positive here, meaning the restoring force is if there is a positive, meaning the restoring force is negative, it's pointing in the opposite direction. I hope you understand why. So now let me show you how to derive this formula from this formula. So when you look here, there is a distance from here to here, so I'll take that as x, and the distance from here to here over. At this point, we can't have the period since it's not a complete circle. Time here will be a t, so t over the time it takes for you to move from this last point, the last position here, up to this point is the period, since it makes a complete circle. So period. Now I need to make my t the subject. So I'll just pause a video and continue from the back, but first let me make my t the subject. T is equal to, if I cross multiply, I get lambda t xt. If I divide, I'll get t is equal to let me just flip and light it properly. Right, so if we divide lambda, I'll get t is equal to xt over t. Let me just transfer over lambda. So t is equal to xt over lambda. Now I should substitute in that equation I got for point O, which is a sine wt. Now I made it as a sine. I replaced omega with 2 pi f. t. So let me subtract this from this t here, since this is the period, I guess. So let me subtract. I'll get y is equal to a sine 2 pi frequency, then t. On t I subtract this factor here, x over lambda period. Now I know that my period is equal to 1 over frequency. So let me just substitute there. Y is equal to a sine 2 pi f t minus x over lambda multiplied by 1 over f. If I multiply a sine 2 pi then ft minus, if I multiply this factor to this, I'll get 2 pi, but my f will cancel, meaning that I'll get 2 pi x over lambda. If you reach at this point, there are some things you know here, but if you've noticed this part, this is the formula for omega 2 pi f, and this part here, I have my wave constant k pi over lambda. Have you seen? So just replace there. Replacing, we get y is equal to a sine omega t minus kx. Okay, so this is the formula when it is moving to the positive, Now the same formula is the general formula. So the general formula it's this same formula, but I'll put plus or minus in between. Y is equal to a sine wt plus or minus kx. So this is the formula for a point P here, this point. And notice when you are at zero, we assume that the time is equal to 0 and the wavelength is equal to 0 when you are here. So these formulas are used at point T when you make these assumptions, and this formula is used at point P. Yeah. So now I think I'm done. I've shown you what the formula is. So goodbye. Take note, this formula will be so useful in our calculations. Yes. And again, this formula I'll show you in the next lesson, where I'll be answering questions that involve these formulas. Alright.